Welcome back, biochemistry students. This is heat lesson 3, where we're going to look at what's called energy diagrams. Hopefully, okay, let me back up. Please pay attention as you're going through this video so that when the questions come, you'll be able to answer them and not have to repeat the video. It would be helpful to have either your notes that you've been taking, if you've been able to print and take notes, or perhaps the PowerPoint open so you can look at things to help you get the correct answers. So hopefully you've printed your notes out and you're taking notes. If not, it would be helpful to have page 4, the energy diagrams, in front of you, because they won't show once I get to the questions. All right. Sorry about that. So an energy diagram is essentially an y-axis, x-axis diagram. The y-axis represents an increasing amount of energy, and the x-axis represents progress of the reaction over time. So over some period of time, the reactants are converted into products, and some amount of energy is either absorbed or released. So we have here two diagrams. One is the diagram of an exothermic reaction. The other is endothermic. We're going to look first at the exothermic diagram. This one represents the combustion of C3H8, which is propane. Things that we burn, like propane or whatever, have a lot of stored chemical energy. Enthalpy is a fancy word for stored chemical energy. Once we have burned the propane, the resulting products have less stored chemical energy. The delta H is negative because a low final value minus a high initial value will give us a negative number. So we'll look at the characteristics of an exothermic reaction. So from the diagram, we could see that the reactants had higher stored energy and that heat was released, giving the products a lower stored energy. Whenever heat is released, it is an exothermic reaction. Delta H is negative, a low final value minus a high initial value. If I were to write the heat in the equation, would it be on the left or right side? Heat is being produced. It is a product of the reaction, so it goes on the right, the product side, with the other products. When heat is released, the temperature increases. Is delta T positive or negative? A higher final value minus a lower initial value gives us a positive delta T. So for any reaction, the delta H and the delta T are going to be opposite in sign. If I were to try to reverse the reaction, if it released heat to create the CO2 and H2O, if I want to try to turn the CO2 and H2O back into propane and oxygen, it's not also going to release energy that way. It is going to require energy instead, and the reaction will be endothermic. Put it back up here a minute. All right. So here's our diagram again. Now we're going to look at an endothermic reaction. Carbon and water will react to make carbon monoxide and hydrogen. Notice that the starting materials have low stored energy. The ending materials have higher stored energy. Where does that energy come from? Heat from the environment is turned into chemical energy. Heat is used up. If there is less heat around, then the temperature will go down. When I calculate the delta H, a high final value minus a low initial value is going to give me a positive delta T. Okay, now we will move on to answer the questions for the endothermic reaction. From the diagram, which had higher enthalpy or stored energy? The products did. Well, if the products have more stored energy, it had to come from somewhere. So heat energy was absorbed and used up. When heat energy is absorbed, it is an endothermic reaction. Is the delta H positive or negative? Again, a high final value minus a low initial value gives you a positive delta H. If I were to write the heat in the equation, heat is required for the reaction to occur. So it goes on the reactant side of the equation, just like the starting chemicals. Does temperature increase or decrease? If we are taking heat away from the environment and turning it into stored chemical energy, the temperature decreases. Is the delta T positive or negative? A low final temperature minus a higher initial temperature gives us a negative delta T. Again, note that delta H and delta T for any reaction are opposite in sign. Reverse reaction. If the original reaction is endothermic, heat is required to create the products. If I reverse the process, then the opposite reaction will release energy and be exothermic. So we're going to rewrite the equations shown on the diagram to include the heat in the reaction. Reaction number 1 is exothermic. Heat is produced, so it goes on the product side with the products. Reaction number 2 was endothermic. Heat is required for the reaction to occur, so it goes on the reactant side, just like carbon and water are required, so is 113 kilojoules of energy in order for the reaction to happen. That concludes today's Edpuzzle presentation. There will be one assignment associated with this. It is a Google Doc assignment that has been posted on Classroom. All right. That's it for today. I will see you or be in touch with you tomorrow. Again, if you have any questions or concerns, please email me. I know that I had a problem with my original version of this video. It didn't work, so I am having to repost it, so I'm a little bit late. Supposed to be posted by 8 a.m. It'll be posted a little bit after 9 a.m. I apologize for that, and hopefully I won't make the same mistake next time. Bye-bye.